Hi students, welcome to Diamond Group of Institution K-CET and NEET online classes. So yesterday we already covered P block elements from first year and second year topics. So from fourth year group elements to from third year group elements and fourth, fifth, sixth, seventh, eighth year group elements. So with the total P block element is over. And today we are going to discuss about the previous questions of organic chemistry, in that some basic principles and techniques. So here some basic principles and techniques in this concept, separation methods, purification methods of the elements, and also estimation of elements in given organic compound and percentage of elements in given organic compound, and IUPAC names of given organic compound. Okay, right? So those concepts today we are going to discuss about that. So in that, the first one, this is the separation method, purification method of organic compound. That is the most suitable method, the most suitable method of separation, the most suitable method of separation of 1:1 mixture of ortho and para nitrophenol. 1:1 mixture of ortho and para nitrophenol is option A, chromatography technique. Option B, crystallization. Option C, steam distillation. Option D, sublimation technique. Okay, so here the question is about what? The mixture of orthonitrophenol and paranitrophenol. So for example, this is a beaker. So in this beaker, so 1:1 mixture of 1:1 mixture of orthonitrophenol and paranitrophenols are present. So this orthonitrophenol and paranitrophenol, so they are separated by using of which technique? So chromatography technique or steam distillation technique or crystallization technique or sublimation technique. So which technique is applicable to the separation of ortho and paranitrophenol mixture? Okay, this is important because of this question is repeated in NEET 2017. Okay, NEET 2017 and 1999 and 1993. So many times this question is repeated. So therefore, once you concentrate on this kind of questions. Okay, so here ortho and paranitrophenol, they are separated. They are separated by steam distillation process. Ortho and paranitrophenol, they are separated by steam distillation process because of in orthonitrophenol, this is orthonitrophenol. Orthonitrophenol is steam volatile compound. Orthonitrophenol is steam volatile compound. So why it is steam volatile? This is orthonitrophenol because of, so this is phenol, benzene OH group is phenol, and at ortho position NO2 group is present. NO2 group is present, therefore it is orthonitrophenol. This orthonitrophenol is steam volatile, means by the passing of steam, so it undergoes volatilization. So therefore it is steam volatile. So why it is steam volatile? Due to the presence of intramolecular hydrogen bond. Due to the presence of intramolecular hydrogen bond. So here hydrogen bonds is existed in hydrogen and oxygen. So therefore here hydrogen bond is forming within the molecule, therefore it is intramolecular hydrogen bond. So due to this intramolecular hydrogen bond, this orthonitrophenol is steam volatile. But paranitrophenol, so this is benzene OH group phenol, and at para position NO2 group is present, therefore paranitrophenol. And another paranitrophenol, so this is the benzene and OH group phenol at para position NO2 group. So paranitrophenol. So one paranitrophenol and another paranitrophenol, in between these two, again hydrogen bonds are existed. So oxygen and hydrogen. So here also hydrogen bonds is existed. So in orthonitrophenol also hydrogen bonds formation takes place, but this hydrogen bond is formed within the molecule, means same molecule. So that's why it is called intramolecular hydrogen bond. But here the hydrogen bonds are formed in between, so are different molecules. So one is one orthonitrophenol and another orthonitrophenol molecule. So therefore different molecules. So in this here hydrogen bonds existed in different molecules. Therefore this kind of hydrogen bond is called intermolecular hydrogen bond. So due to the presence of this intermolecular hydrogen bond, it is non-steam volatile. It is a non-steam volatile. Because of intramolecular hydrogen bonds are weaker when compared with intermolecular hydrogen bond. So therefore, orthonitrophenol is steam volatile compound. So means by the passing of steam, it is undergoes volatilization, but paranitrophenol is non-steam volatile compound. Why it is non-steam volatile compound? Because in paranitrophenol, intermolecular hydrogen bonds are present. So therefore, once you observe, this is the beaker. In this beaker, 1:1 mixture of ortho and paranitrophenol is present. By the passing of steam, here this orthonitrophenol is steam volatile compound. Therefore, that is undergoes volatilization. But here paranitrophenol is non-steam volatile. So therefore, that paranitrophenol is remains in that beaker. So therefore, two compounds are separated by the steam distillation process. Okay, so answer C. This is repeated in 2008, 2017 question and 1999 and 1993. So therefore, better to focus on this type of question. Second one, the IUPAC name of the compound. Okay, so here one of the organic compound is given. So this is organic compound. And what is the IUPAC name of this compound? So we are going to find out that option A, 5-formyl hex-2-ene 3-one, 5-methyl 4-oxo-hex-2-ene thiol, 3-keto 2-methyl hex-5-ene all, 3-keto 2-methyl hex-4-ene all. Okay, so this is NEET 2017 question. NEET 2017 question. Right. So in any for any organic compounds, if you want to give the IUPAC name, we better to follow the this rule. Okay. What is that? Secondary prefix first, next primary prefix, and next root word, next primary suffix, and finally secondary suffix. Okay. So we better to follow this rule for organic compounds in the part of IUPAC nomenclature. Okay, right. So first we go to secondary prefix. Secondary prefix, it gives information about what? Secondary prefix, it gives information about the substitutions. Okay, substitution. And primary prefix, it gives information about cyclic compounds. Okay, cyclo, like that, cyclic compound. And root word, it gives about information about number of carbons present in a given organic compound. And primary suffix is used for, it is used to expression of whether the organic compound is saturated or unsaturated. If it is saturated, we are using the ane. If it is unsaturated, ene or ine. And secondary suffix, it gives information about the functional groups. Okay, right? So therefore, first we go to secondary prefix. Okay, secondary prefix. Secondary prefix, it gives information about what? Substitution. Okay, so first, so here this is C double bond O, C double bond O, one side hydrogen, another side carbon. Here the carbon. So this is one functional group, that is aldehyde. Okay, because of C double bond O, one side carbon, another side hydrogen. This is aldehyde functional group. And here again C double bond O, this is the carbon. C double bond O, one side carbon and another side also carbon. Okay, it is ketone functional group. So aldehyde functional group and a ketone functional group. And here this is the substitution. Methyl group is the substitution. Okay, methyl group is the substitution, because of we have to select the longest chain. Okay, longest chain. Therefore, aldehyde number 1, number 2, number 3, number 4, number 5, number 6. 6 carbons. Okay, longest chain rule. 6 carbons. Next one, here second carbon has one substitution, that is methyl group. Second carbon has one substitution, that is a methyl group. Okay, and here fourth carbon, it has a double bond. Therefore, ene. Double bond is nothing but ene. But here one aldehyde group is present and one ketone group is present. So if the compound has two functional group, then we are going to priority order. Okay, right? Priority order is what? Priority order, it gives information about which functional group is more priority. Okay, so carboxylic acid is more priority, next sulfonic acid, next texture, like that. So here, if aldehyde and ketone, two functional groups are present, then in that situation, one is treated as a functional group and another one treated as a substitution. Okay, so which one treated as functional group and which one treated as substitution? So that information is obtained from the priority order. Okay, so therefore refer to priority order. In that, aldehyde is more priority. Aldehyde is more priority than the ketone. So therefore aldehyde act as a functional group. Here ketone act as a substitution. So substitution, here secondary prefix, it gives information about the substitution. So here first we go to secondary prefix. Secondary prefix, it gives information about the substitution. So here which are the substitution? Second carbon methyl group is substitution, and third carbon keto group is the substitution. So keto substitution, methyl substitution. So if two substitutions are present, then we have to follow the alphabetical order. So here keto K, methyl M. So K first. Therefore 3 keto. So in place of secondary prefix here, 3 keto. Next, another substitution what? 2 methyl, 3 keto, comma 2 methyl. So secondary prefix information is over. So 3 keto, 2 methyl, secondary prefix information is over. Next, to go to primary prefix. Primary prefix, it is used to expression for cyclic compounds. So it is not a cyclic compound, therefore primary prefix is absent. Next, we go to root word. Root word, it gives information about number of carbons. So therefore 1, 2, 3, 4, 5, 6 in the straight chain. 6 carbons is nothing but a hex. Okay, eggs. And primary suffix. Okay, root word is over, number of carbon 6 eggs. Primary suffix. Primary suffix, it is used to expression of the compound is saturated compound or unsaturated compound. That means this compound containing all single bonds or double bond, triple bond is present. So once you observe, yes, here double bond is present, and that double bond present at fourth carbon. So therefore 4 ene. Okay, so in place of primary suffix here 4 ene. Okay, 4 ene. And here finally secondary suffix. Secondary suffix, it gives information about the functional group. So here which one functional group? Aldehyde functional group. So if aldehyde acts as a functional group, then the secondary suffix end with al. So therefore 3 keto, 2 methyl, eggs 4 in all. It is a IUPAC name. 3 keto, 2 methyl, eggs 4 in all. It is the IUPAC name for this compound. So this is NEET 2017 question. Question number 3. So this is a 2015 question. Total number of pi bonds. Total number of pi bond electrons in the following structure. So here this is the structure of organic compound. Structure of organic compound. This is 2015 question. So in this they are going to ask what? Number of pi bond electrons. Number of pi bond electrons. So how many pi bonded electrons are present? Option A 12, option B 16, option C 4, option D 8. So here first we have to count the number of pi bond. So 5 bond. So 2 bonds. In these 2 bond, one is sigma, another one 5 bond. 5 bond 1, 5 bond 2, 5 bond 3, 5 bond 4. So total number of 5 bonds are 4. Total number of 5 bonds are 4. So one 5 bond contain 2 electrons, 2 5 electrons. Therefore 4 into 2, 8 5 electrons are present in that molecule. So therefore option D. So sometimes once you observe students, sometimes they are given the this is simply questions also. Okay, so therefore we have to focus on these kind of questions also. Next, so very important fourth question, Dumas method. This Dumas method and Jaldal methods. Okay, Dumas method and Jaldal method, those two methods are used to find out the percentage of nitrogen. Okay, percentage of nitrogen. So therefore, mostly you better to concentrate on Dumas method and Jalda's methods and equations and problems. Okay, that is important. Okay, here fourth question, in Dumas method, for estimation of nitrogen, 0.25 grams of organic compound. Okay, here organic compound mass is given, that is 0.25 grams of organic compound gave 40 ml of nitrogen. Okay, in Dumas method for estimation of nitrogen, 0.25 grams of organic compound gave 40 ml of nitrogen, means volume is given, mass is given. Next, that 40 ml of nitrogen collected at 300 Kelvin temperature. 300 Kelvin temperature, so temperature value is given, and 725 mm pressure, 725 mm pressure. If the aqueous tension at 300 Kelvin is 25, if the aqueous tension at 300 Kelvin is 25 mm, then the percentage of nitrogen in the compound is what? Then the percentage of nitrogen in the compound is what? Okay, so we have to find out what, student? Percentage of nitrogen. So it is also 2015 question. Option is 16.76, B 15.76, C 17.36, D 18.20. So first, for any type of these questions, first we have to return some data. So which data is given what in that question? Okay. So here first, mass of organic compound. Mass of organic compound is 0.25 grams. Next, experimental values and STP values. Experimental values and STP values. So here experimental value 40 ml volume. So V1 is 40 ml and V2 value you have to find out first. Next, so 300 Kelvin temperature, T1 value 300 Kelvin temperature, and 725 mm pressure. So pressure 725 mm, but it is aqueous tension. So therefore 725 minus 25. So 725 minus 25, that is 700 mm P1 value. Next, these are STP values. T2 temperature in Kelvin 273, P2 pressure in mm 760 millimeter mm. Okay, so these are the given values in that question. Related equation is P1 V1 by T1 equal to P2 V2 by T2 in Dumas method. Okay, this is the related equation if P1 V1 T1 value, if they are given like that. So therefore, in this equation, first we have to find out the V2. Therefore, V2 equal to P1 V1 T2 by T1 P2. Okay, so P1 V1 T2 by T1 P2. So substitute these values in this equation. So P1 value 700 and V1 value 40 and T2 value 273 and T1 value 300 and next P2 value is 760. So therefore substitute these values in this equation, and by the simplification we get 33.52 ml of nitrogen, that is the V2 value. That means from this given data, first we are find out here V2 value. So in Dumas method, 22,400 milliliter or 22.4 liter of nitrogen at STP weight is 28 grams. Okay, 22,400 milliliter of nitrogen gas at STP weight is 28 grams. But here 33.52 ml of nitrogen at STP weight is how much? Okay, weight is first we are find out V2. Next one, 22,400 milliliter of nitrogen at STP is 28 grams. But at this value, how much grams is present? So 33.52 ml of nitrogen at STP weight is how much? Therefore, 33.52 into 28, 33.52 into 28 by 22,400. In this simplification, 0.0419 grams. Finally, percentage of nitrogen equal to, so here uh, ma mass of or weight of nitrogen at STP. Okay, weight of nitrogen at STP and by weight of organic compound is taken into 100. So here weight of nitrogen at STP is 0.0419 by weight of organic compound is taken 0.25 into 100. In this simplification 16.76 percentage of nitrogen is present. So therefore A is the answer. So next to question number 5. In Jalda's method, for estimation of nitrogen present in a soil sample, ammonia evolved from 0.75 grams of sample neutralized 10 ml of 1m H2SO4. Then the percentage of nitrogen in the soil is what? Then the percentage of nitrogen in the soil is what? Okay, option A 37.33, 45.33, 35.33, 43.33. This is 2014 question. Okay, here just now I'm told to you Dumas method and Jalda's method. Those two methods are used to find out the percentage of nitrogen and important methods. Okay, so I'm already explained the Dumas method with one kind of example. Here I'm going to explain the Jalda's methods with one another kind of example here. So Jalda's method. So first, directly I'm entered into the hint here. H2SO4 acid, ammonia is the base, so therefore his base is neutralized by the acid H2SO4 and forms the ammonium sulfate in that estimation of nitrogen. So this reaction takes place. See here 10 ml of 1m H2SO4 is used. 10 ml of 1m H2SO4 is used. That means here milliliter, volume in milliliter and molarity is given. H2SO4 molarity is 1 and volume is 10 in milliliter. Therefore, molarity into volume in milliliter equal to millimoles. Okay, millimoles. So therefore 10 ml molarity into volume. So this is molarity into volume is nothing but 10 millimoles. Next, here so H2SO4 10 millimoles means ammonia 2 times greater than H2SO4. Therefore 2 into 10 20. Ammonia consumed is 20 millimoles. Acid used for that, this acid used for the adsorption of ammonia is 20 minus 10 millimoles. That is nothing but 10 milliliter of 2 normality. If normality is 2 or molarity is 1 for this H2SO4. 10 ml of 2n or 1m H2SO4. Therefore, percentage of nitrogen, this is the Jaldal method equation. Percentage of nitrogen equal to 1.4 into normality into volume by weight. So 1.4, here normality is 2, normality 2 and volume is 10. Okay, volume is 10 by, so weight grams. So therefore 0.75 grams. So 37.33 in simplification, option A. Next, question number 6. So this is mains 2011 question. The correct IUPAC name for this organic compound. The correct IUPAC name for this organic compound. So these are given here. They are given different options. See here, first we have to select the longest chain rule. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, but double bond is priority here. So therefore, number one, number 2, 3, 4, 5, 6. Okay, so this is the longest chain rule and double bond priority. Next, so therefore, I've already explained the clue: secondary prefix, primary prefix, root word, primary suffix, secondary suffix. You better to follow like that. But I'm generally explained here. So here number of carbons 1, 2, 3, 4, 5, 6. Number of carbons 6 means root word is hex. So hex, option A hex, option B hept. Therefore this is wrong. Option C hex, option D also hex. Maybe A, C, D. Next one. So first carbon containing double bond in, 1 in. So therefore X 1 in. This is the 5 in wrong. This is 1 in. Therefore A and D maybe. Next, here third carbon, this side contain 1, 2, 3 propyl group and fourth carbon contain ethyl group. So 3 propyl, 4 ethyl. Okay, 3 propyl, 4 ethyl. In these two, alphabetical order. So propyl is first. Therefore, ethyl is first. Therefore, 4 ethyl, 3 propyl, hex 1-ene is the answer. And another important concept, the lacine extract is boiled with concentrated HNO3. This is also mains 2011 question. The lacine extract is boiled with concentrated HNO3 while testing for halogens. By doing so, it what? So, decompose of sodium sulfide and sodium cyanide formed help in the precipitation of AgCl, increase the solubility product of AgCl, and increase the concentration of NO3 minus ions. Okay, so lacine extraction. See here, lacine extraction is used to identification of nitrogen, identification of sulfur, identification of halogen. Okay, so this is the lacine extraction process. In this lacine extraction process, first organic compound is fused with the sodium metal, dry sodium metal, and it is boiled in a fusion tube, and we have to prepare the sodium extraction first. And in that sodium extraction, if nitrogen is present, if the nitrogen is present in organic compound, that nitrogen is converted into sodium cyanide. And if the sulfur is present in that organic compound, so that sulfur is converted into sodium sulfide. And if the halogens are present in that organic compound, that halogen is converted into sodium halide. So now imagine like this. This is the sodium extraction. In this sodium extraction, sulfur, nitrogen, halogens are present. Example. So sulfur is converted into sodium cyanide, sodium sulfide, nitrogen is converted into sodium cyanide, halogen is converted into sodium halide. But this lacine extract is boiled with concentrated HNO3 while testing for halogens. Now I am going to test for halogens only. Okay, now I'm going to test for halogens. Okay, so test for halogens. In this test for halogens, so here these two compounds are disturbed for the test. Okay, because of sodium cyanide is present and sodium sulfide also is present. Okay, sulfur and nitrogen also present. So therefore, we have to remove the sulfur and nitrogen from that sodium extraction. Okay, after that only we are going to conduct the test for halogen. That is the better thing. Therefore, we have to remove the sulfur and the nitrogen first. So this sulfur is in the form of sodium sulfide and that nitrogen is in the form of sodium cyanide. Therefore, sodium cyanide and sodium sulfide, these two are removed from that lacine solution by the addition of, by the heating with concentrated HNO3. Okay, that is the use of concentrated HNO3. So therefore, concentrated HNO3 decomposes sodium sulfide and sodium cyanide. Concentrated HNO3 is decomposes sodium sulfide and sodium cyanide. Then after boiled this lacine solution with concentrated HNO3, that sodium sulfide and sodium cyanide decomposes and remaining halogens only present. Now we are easily test this halogen test in this lacine solution. So therefore, boiled with HNO3 due to the decompose of sodium sulfide and sodium cyanide is formed. Answer A. So next question number 8. Some meta-directing substitutions in aromatic substitution are given. Which one is most deactivating group? Which one is most deactivating group? So these are the functional group: carboxylic acid, nitro group, and cyanide and sulfonic acid. These are the functional groups. So if these functional group present on aromatic ring, if these functional groups are present on aromatic ring, so which functional group is most deactivating group and meta-directing group? Which functional group is among these four? Which functional group is most deactivating group and meta-directing group? Okay, so here we are easily find out the answer, that is NO2. We already well known about that, because of here NO2 group is minus IE group and inductive effect group and minus mesomeric effect group. So therefore, NO2 group is minus IE group and minus mesomeric effect. Due to that character of NO2, it is meta-directing group and also ring deactivating group. Okay, right? So among these four, which one is most deactivating and meta-directing group? NO2. What is the reason? It has minus IA group and minus ME group character. Okay, right? So therefore, option B, that is NEET 2013 question. Simple answer. Next, question number 9. What is the hybridization state of benzyl carbonium ion? This is Karnataka NEET 2013 question. So this is benzyl carbonium ion. So that benzyl carbonium carbon hybridization is what? sp2, spd2, sp2d or sp3. Okay, right? So here carbon contain the positive charge. Carbon contain the positive charge. Therefore, simply it is a sp2 hybridization state. Next, question number 10. Nitrogen detection in an organic compound. Nitrogen detection in an organic compound is carried out by Larsen test. Again, Larsen test. Nitrogen detection in organic compound is carried out by Larsen test. The blue color formed correspond to which of the following formula? So this is Karnataka NEET 2013 question. So option A, B, C, D. Okay, right? See here, Larsen test. Just now I am explaining the Larsen test. Larsen test used to detection of nitrogen and used to detection of sulfur and used to detection of halogens also. Okay, so in this Larsen test, first we have to prepare the Larsen solution or sodium extraction. Okay, right? Sodium extraction. So therefore, for example, this is organic compound X, organic compound X. Now, this organic compound, it contains what type of elements? Either nitrogen is present or sulfur or halogen. So therefore, we have to prepare first this organic compound is converted into Larsen solution. Larsen solution. So how it is converted into Larsen solution? This organic compound is taken into dry test tube, that is a fusion tube, and by the addition of sodium, metal and boiled sometimes and this boiled sometimes and extract that solution. So organic compound and sodium metal and boiled sometime and extracted that solution is converted as a Larsen solution. And now this Larsen solution is taken into one test tube. Okay, Larsen solution is taken into one test tube. And to that, for now this Larsen solution, for this Larsen solution, I am going to add ferrous sulfate. Okay, ferric sulfate. I am going to add the ferric sulfate. So, if the ferric sulfate solution is added to this Larsen solution, if it is forms the Prussian blue color, if it is forms the Prussian blue color, that indicates what? Presence of nitrogen in this organic compound. Okay, so formation of Prussian blue color, it indicate the presence of nitrogen after adding of ferric sulfate to the Larsen solution. So the question is, so here nitrogen is present, that is indicated by the Prussian blue color formation. So this Prussian blue color composition is what? Option A, or B, or C, or D. Okay, so this is the question. So therefore, ferric sulfate solution is added to sodium extraction. So ferrous sulfate solution is added to sodium extraction, then it is converted into Fe4, FeCN6 taken twice. So this is called ferric ferricyanide. This is called what? Ferric ferricyanide. So ferric ferricyanide. So this compound color is Prussian blue color. Due to the formation of this compound, so it is look like a Prussian blue color, that it indicate the presence of nitrogen. So therefore, this is the answer. This is Karnataka NEET 2013 question.